You are welcome to this session of vector calculus. The previous session vectors. Today we are going to look at how to calculate special unit vectors. So we define that if it's of a vector which is made up of A1, A2, A3 in 3 dimensions, then the unit vector is defined as vector of the hat, which is the vector A over the magnitude of the vector A. So in this case, the magnitude will find as square root of the component squared, A1 squared plus A2 squared plus A3 squared, right? So our unit vector is given as vector A over the magnitude, which is square root of A1 squared plus A2 squared plus A3 squared. So today we are going to build on this and then define what we call special unit vectors. Special unit vectors. These special unit vectors are all associated with the axis. We have the OX axis, Y axis, and then the OZ this axis. So we'll define the special vector as vector I, which acts in the OX axis, and if it's 3 dimensional, then it has coordinates 1, 0, 0. If it is 2 dimensional, that is for 3 dimensions. Then for 2 dimensions, then this one becomes 1 and 0, 2 dimension, right? For 2 dimension. Then we'll have vector J, which represents the vector on the axis. So this one is the x-axis, and then we have the y-axis defined as J, and J is given as for 3 dimensions 0, 1, 0, and then for 2 dimensions J becomes 0 and 1. Then on the third one will be the z-axis. On the z-axis, O axis, then we have vector K as the special unit, which is defined as 0, 0, 1 for 3 dimensions, and then K will be for 3 dimensions it becomes 0, 0, 1. Unfortunately, we don't, for 2 dimensions it's made up of only OX and OY, so we don't have the Z component for 2 dimensions. The Z component only occurs when we have 3 dimensions. So for example, if which we knew it as vector, for example 3 minus 2, 4. So far this is how we present this vector in this parenthesis form. But now using the unit vector, A can now be defined as 3 in the direction of the unit vector I in the x-axis minus 2 in the direction of the y-axis, whose unit vector is J, and then we have plus 4, which is the Z, and that is going to be 4 times the unit vector K. So this is another way of representing vectors using the special unit vectors. So in this case, any vector can present as this way, or you can present it using the special unit vector. We can represent any vector in terms of any of them. So they all present the. So we can also, given a vector, we can always find the unit vector. So if the unit vector of this vector, given vector A, which is given as 3 minus 2j 4k, the definition of unit vector is still the same. So we have unit vector A is given as the vector A divided by the magnitude of vector A. So in this case, the magnitude of vector A, also the formula remains the same, square root of the square of the components. 9 squared, 3 squared, that will give 3 squared plus minus 2 squared plus 4 all squared. So if you do the addition beneath the square root, you're going to have 3 squared is 9 plus negative 2 squared is 4 plus 4 squared, which is 16, and this will sum up to square root of 29. So we can still define the unit vector using the special unit vector as 3 divided by square root of 29i minus 2 over square root, then plus 4 over root of 29k. So that is how we can also represent unit vectors in terms of the special vectors. And since we have the special unit vectors as I, we can see that the magnitude of I, like any magnitude of a unit vector, is 1. So this one is 1 because if you take 3-dimensional, you're going to have 1 squared plus 0 squared plus 0 squared, and that will give us 1. Likewise, magnitude of vector J will also give us 1, and magnitude of vector K will also give us 1, since all special unit vectors. So in a nutshell, we can represent vectors in terms of special unit vectors, and then we can represent vectors in terms of using the parentheses, and all will work out there. But we have unit vectors, special unit vectors. It makes the algebra, addition, subtraction of vectors, makes them together, components, and then subtract them, or what to do. For example, if you are asked to perform this, if given, for example, given vector A to be minus I plus 2j plus 3k, and vector B is given as 3i plus 4j minus 2k, it's always easier to work with this. So for example, find vector A plus vector B, 1, and then 2, find vector B minus vector A. So the solution will be like this. If you want to do 1, if you are doing 1, A plus B, vector A plus vector B is vector A, which we had it to minus I plus 2j plus 3k, and we're going to add vector B. Vector B is 3i plus 4j minus 2k. Then you see that it's easier adding them together. If you look at the I components, you can operate on the I components. If you look at the j components, you can do that. Let's go ahead. So for the i's, we have minus I plus 2i, that will give us plus 3i, that will give us 2i, right? Then we have 2j plus 4j, that will give us 6j, and then we have 3k minus 2k, that will give us positive k. So that is how we can, it makes life very convenient if we apply the unit test. Likewise, if you go to number 2, we want to find vector B minus vector A. Vector B will come first. In this case, vector B is 3i plus 4j minus 2k. And then you are going to subtract. And we learned that anytime there's subtraction, you always protect whatever is coming after the subtraction. for a bracket. So you put vector A, which is minus I plus 2j plus 3k. So if you open the bracket, you're going to have 3I plus 4j minus 2k. Then open the bracket. Minus times minus become positive I. Negative times positive will give us negative 2j. And then negative times positive will give us negative 3k. So now it becomes easier to assemble them component by component. So if you take 3I plus I, that will give us 4I. Then 4j minus 2j will give us 2j. And then minus 2k minus 3k will give us minus 5k. So that does it for working with vectors with a special unit. So with this one, we will come to the end of using learning about the special unit vectors. In the next lecture, we are going to apply this concept and looking at further manipulations with vectors. So hope to see you in the next lecture, and thank you very much.